Well, good afternoon and welcome to the Versarien Investor Webinar. My name's Tim Metcalf, Managing Director of IFC Advisory, which is Versarien's Investor Relations Advisor. With me this afternoon, I've got Steve Hodge, the CEO of Versarien, Chris Lee, the CFO, Roberto Clemente, who's Nanomat CEO, and Ben Harris, who's Head of 3D Construction Printing at Versarien. The team will take you through a presentation, and then at the end of the presentation, we'll have the opportunity for a question and answer session. I'd like to thank everybody who's submitted questions in advance. Really appreciated. And many of those have helped us shape the presentation, and hopefully you'll see that they are actually answered during the course of the presentation. There are one or two that I don't think have been fully addressed, and I'll be putting those to the team at the end of the presentation. But we do welcome further questions. Unfortunately, with the number of people we've got online today, it's not possible to go to you individually, ask you to unmute and put your questions directly. But if you do have a question, please use the Q&A function in Zoom, button at the bottom of your screen, type your question in. I will be looking through those and then we'll put them to the team at the end of the presentation. Okay, well, without further ado, I will hand over to Steve to start the presentation. Steve.
Thank you, Tim, and again, thank you for everyone for joining at whatever time zone you're in. Hopefully, we'll be taking you through quite an in-depth presentation about the last 12 to 18 months within Versarien and the changes we've been going through. And as Tim mentioned, joined by a few of my colleagues here today to support this presentation. Just a disclaimer here for the presentation to flick through. As you're aware, Versarien have been working on graphene now for a number of years. Graphene was first isolated in Manchester in the UK in 2004. So now we're in graphene's 20th year. Of all these fantastic properties graphene can harness, we're still seeing this emerging industry that's made steady progress. But just to highlight that graphene is one of many materials that Versarien is working on. Graphene will remain at the heart, but we're also working with a range of zero-dimensional metal nanoparticles, one-dimensional carbon nanotubes, and other two-dimensional materials in the graphene family. So whilst graphene is at the heart of Versarien, we utilize all the properties that innovative advanced materials can offer, such that we can optimize product performance and give our customers the best product that they require. So in summary, we're an IP-led advanced engineering materials company. That's what we've been for a number of years. And we utilize proprietary solutions and technology that we take out of academia from UK and overseas institutes, and we create innovative engineering solutions. And to date, we are a globally recognized nanomaterials company. We've got a wide portfolio of high-quality materials, and this is underpinned by our UK-based R&D, which we're performing within graphene centres of excellence, such as Cambridge and Manchester University. In terms of the board, currently myself and Chris on the call make up the exec team. I've been CEO since July 2023, but I was appointed to the board back in 2021. And my background is 15 years or so in advanced materials. My PhD was working on carbon nanotubes, graphene's older brother. And so I've had a vast experience with a range of different materials. Our non-exec team, we have very strong support from Diane Savoury, who spent a long time with Superdry, taking them from SME to floating on the London Stock Exchange back in 2010. Susan Bowen, who has recently become the CEO of the Digital Catapult in London. And Sir Ian Gray, who was knighted last year, spent a long time in the aerospace sector and as chief exec of Innovate UK, and again brings a very strong technical background to the business. So in terms of our operations, as advanced materials and graphene has continued to gain traction, we've had to reduce our monthly operating cash burn over the last 18 months. And we've seen that significantly fall from around 228,000 to around 128,000 at this present time. So we've been doing that by firstly reducing our overheads and particularly some R&D expenditure. We're focusing now on our core advanced material subsidiaries, and that means divesting our mature businesses. We're in the process of selling our chemical vapor deposition assets that are in South Korea, and we've switched to a manufacturing licensing model So we're monetizing that IP that we've developed over the last 10 years and also that we've acquired. So these are our 5 core businesses. Versarien Graphene, that was established here in Gloucestershire a few years ago, and that's dedicated to manufacturing our graphene and advanced materials. 2D Tech was a spin out from the University of Manchester that was acquired in 2014. And again, that technology we're still developing and scaling up the production of graphene powder that came from 2D Tech, and that's being performed now in Longhope in Gloucestershire. Cambridge Graphene was acquired in 2017, and that business grew from developing novel 2D inks and dispersions utilizing graphene and other similar materials. In 2018, we acquired Nanomat in Spain, so that was our first venture overseas, and Nanomat's focus is on energy storage materials, and Roberto is going to talk you through some of the activity that Nanomat's been performing over the last 12 months. In 2021, we established Versarien Korea. Again, that was following acquisition of assets from Hanwha Aerospace, so a lot of IP and also the equipment to manufacture high-quality single-layer graphene. And that's equipment that we're in the process of selling to another Korean partner at the moment. So these are our bases in the UK and overseas. So in South Korea, we are co-located with Graphene Lab, which was a company that invested in Versarien during our move to South Korea in 2021. And we also have a foothold still within the Geek in Manchester and people located within the Cambridge Graphene Centre in the University of Cambridge. So in terms of those mature businesses, the intention was to look at selling both of those together. So AAC Cyroma, which was a plastics business looking at injection molding and vacuum forming of products, mostly for the automotive sector, and Total Carbide, which is our hard-wearing tungsten carbide company. Unfortunately, because of the differences in these businesses, they're quite diverse. The customer base is quite diverse, as well as locations. It's not trivial to sell them together. So back in September 2024, we announced the sale of AAC Cyroma to Harper Bennett Limited, and the first of those installments is due in this month. With Total Carbide, we have ongoing discussions with 2 parties, but these are still in fairly early stages. In terms of the CVD assets, as I mentioned, these are equipment we acquired in 2021. In March 2024, we entered into an agreement with MCK Tech in South Korea. So MCK Tech is a relatively young company with the CEO, Dr. Sungmin Cho, who was one of the initial inventors and is on most of the IP that belongs to Versarien. And so it seems a natural fit to sell it to an owner that actually has ideas and knows how the equipment runs and operates and can run a successful business using this equipment. So that was for a consideration of £604,000, together with a license agreement for 5 patents that belong to Versarien. And so far, we've received just over half of that money, with the last payment of £242,000 due to Versarien by the end of this month. So the group structure currently looks like this. We've got 43 people in total across the whole business, 21 of those sitting within Total Carbide. So the remainder are within the advanced materials divisions. We've notably increased our stake in Nanomat from 62% to 90% over the last 6 months. And that was a convertible loan that will allow Nanomat to now apply for local government funding, which could be quite significant for the company. Versarien Korea is 85% owned by Versarien, with the other 15% owned by our investor Graphene Lab, based in South Korea. Chris, I'll pass over to you for this slide.
Thank you very much, Stephen. Good afternoon, everybody. Obviously, with the audit ongoing at the current time, there's a limited amount that I can say about the current financial position, but I just wanted to address a couple of points, if I may. If we look back to December 2023, we announced that the company's projections were showing an EBITDA positive position being reached in the second half of 2025, obviously assuming the conversion of sufficient opportunities into revenues for the company. Our current projections have not changed in this regard, so we're still expecting the same thing, but obviously it depends on a number of assumptions. In terms of the balance sheet, one of the things I know is of interest to shareholders is where we are with the Innovate UK loan. And we announced back in December 2022 that Innovate UK had offered to vary the terms of that loan by deferring commencement of the capital repayments so that they began in August 2025. So that first capital repayment of 500,000 is due around the time that we reach break even. Clearly, that's an issue that we have got to address and discuss with Innovate UK. But just to provide some level of comfort, and obviously I can't speak for Innovate UK, one only has to look at their website, and there's some remarks on there that says if you cannot particularly pay back in line with the loan conditions, that they will work with the company to agree on a way forwards. So that's an update on where we are currently. I know a few questions have come in which are financially related, so I'll just address those whilst I'm on this slide. One was, can we be certain of the sale proceeds from AAC? The answer is there is no certainty, but as Steve has already said, we hold legal charges over the assets of AAC to secure our position as far as possible. We hope that AAC is in good ownership. We marketed it for over a year, and we see this as a good outcome for us as we wish to use any funds that we have got for developing the technology business, not in supporting mature and possibly cash-consuming businesses. Another question was, are we close to selling Total Carbide? Steve has said we're already at an early stage with two parties who've expressed an interest, and if that develops any further, then to a point where we need to update the market, then we would do so. And lastly, people are asking, will the final payment be made by MCK by the end of the month? We have not been informed otherwise. We understand that they're working towards payment, and strategically we wish to continue to work with MCK to access the CVD technology and future licensing income. So obviously it would be good to get that payment in and to continue what we see as a strategic opportunity with MCK. So hopefully that addresses a few questions, and I'll hand you back to Steve now.
Thanks, Chris. So, as I say, the strategy really has been to become a manufacturing light business, monetize our know-how that we have developed and we've acquired over the last 10 years. So, as commercial traction continues to develop, we also look forward to developing commercial relationships with our licensing partners. So we now have 3 partners, Graphene Lab, MCK Tech, and Montana Chimica on board, who I'd like to go into a bit more detail in a few slides' time on those partnerships. So just a reminder on actually what the products are that Versarien is selling. So we produce everything from a range of nanomaterials, intermediates, as well as enhanced products. So in terms of those nanomaterials, we go from the single atoms. So in South Korea, manufacturing the single atom thick CVD graphene and accessing that now through MCK Tech. In the UK, we are manufacturing powders of graphene and boron nitride, as well as some lab scale graphene oxide. We're also producing large scale graphene inks and dispersions, and we're also putting those materials into intermediate materials such as polymer compounds and master batches. So you would have seen our launch of polygreen thermoplastics in 2023. In Spain, Nanomat are looking at the hybrid nanomaterials, so combining graphene and carbon materials with other metallic and metal oxide nanoparticles to bring about synergistic property enhancements. And we go everywhere from the single molecules all the way up to superstructures. So we've got our 2 key brands, which are graphene wear in terms of the leisure, so graphene enhanced rubbers for footwear, and also graphene coatings for textiles that has been uptaken by a number of companies. In construction, we have our brand Cementine, which is low carbon graphene admixtures for construction, and we'll talk a bit more in detail about the 3D construction side of things later. So we've created different websites for those brands, grapheneware.com and Versarien Construction, for those people that are more focused in those industries that don't want to get lost within our Versarien webpage. This is our IP as it stands. We have around 114 patents globally. There are a few extras that we also license from University of Cambridge, for example, and 19 of those patents are now licensed to partners in South Korea. And as you would have seen, we've licensed some technology in terms of the graphene ink manufacturing to Montana Chimica in South America. And I was lucky enough to go and visit Montana a couple of weeks ago in Brazil. We also have royalty and sales agreements in place with companies, and we're still pursuing a number of graphene-ware opportunities. Mostly I see this happening through companies such as Go to Gym, so that they're doing a fantastic job in South America, engaging with a number of companies to supply both graphene-ware formulations and graphene printed fabrics. With Flux Footwear, we're also working on larger orders, and we're trying to fulfill those at the moment. And again, we've had to look at moving some of the manufacturing and the compounding overseas where we can get lower pricing. In terms of Umbro, we haven't seen any additional ranges being developed this year, and that's because Castor now own the license to some of the pro training and some of the professional sports from Umbro, and so that's conversations we need to start engaging with to try and get our products back into those clothing ranges. So a bit on our licensing partners. Graphene Lab, as I mentioned, they were a strategic investor into Versarien back in 2021. And we have 14 patents which are licensed to them for CVD graphene manufacturing. So their focus at the moment is looking at a number of graphene applications, but with a main focus on extreme UV pellicles. These are materials used in the semiconductor fabrication industry. And recently they announced with some new patented technology that they can exceed 90% transmittance, which is quite a big milestone. And hopefully they can continue to develop that technology further. MCK Tech, as we've mentioned, again, we'd like to maintain strategic relations with the team. They've recently announced a couple of government projects they're working on. The first is utilizing graphene in electric vehicle heated windscreens. And that's a project totaling around £750,000 running for the next 4 years. And they also have an ongoing project looking at environmental pollution and monitoring PFAS, so these forever chemicals which are commonly found in water, and developing graphene-based sensors for detecting those. They've also announced and are doing some work with the US Army on stealth applications, and they're starting to now provide various scaled prototypes at 6-inch and next year 12-inch samples of graphene for this application. Also looking at developing graphene enhanced wires for the audio market and expecting to see increasing volumes next year. So things very positive, and we don't have any concerns about MCK being able to pay the rest of the machinery costs. In Montana, Chimica in Brazil, this was again images of me visiting a couple of weeks ago in Sao Paulo, and also attending a graphene conference in the north of Brazil. So it's quite exciting to see that Montana have now launched their advanced materials business called Soma, and this will sit inside Montana Chimica. So back in March, we entered into a manufacturing license and know-how agreement. So we already have provided some training to Montana's staff who came over to the UK. And again, we're exchanging that knowledge and helping Montana to support their customers and to help them build the market for graphene in Brazil. And it's already quite promising to see that they've been getting quite exciting results using cementine in various different construction projects in Brazil. And hopefully we can now look to also support them in trials before Christmas, and also future trials coming up after Christmas. So again, gives me more confidence that cementine could be applicable in multiple parts of the world. So looking at the future focus, we've just come out of the 10-year graphene flagship program last September. And looking forward in Europe, there's now the creation of a new initiative called Innovative Advanced Materials. We've already signed up as a SME member, and we've been following it quite closely. The 4 strategic research and innovation areas have been named as construction, energy, mobility, and electronics. So actually, the work that Versarien has been doing to date nicely fits with this agenda, particularly construction, where we're already working on low carbon construction, and also our 3D printing fits nicely within the automation and digitization part of that. Energy and mobility, I guess, is a key focus of Nanomat, looking at better performing energy storage systems across a range of industries. And electronics, we already have our conductive and functional inks within our graph inks portfolio. And also, you may have seen this week, we've launched our first high-tech CVD graphene-based electronic device, which is a biosensing platform. So hopefully being aligned with this strategy will allow Versarien to pivot and to access significantly larger grant funding or commercially funded R&D programs with various large companies that are expected to join this initiative. So just to talk you through each of those 4 strategic areas. Construction, I mentioned we have two initiatives. We're looking at low carbon graphene admixtures, and we're also looking at 3D construction, which Ben is going to talk you through. So of course, construction is a huge area, but it's of huge importance, particularly for tackling global carbon emissions. So we know that cement is responsible for 8% of global CO2 emissions. So many companies are now striving to look at ways in which we can improve the efficiency or reduce the usage of cement in our construction. So to date, we've done lots of trials, various mixed designs with our 17 admixture. So what we're producing, as I mentioned, is a water-based solution that can be utilized in place of some of the water that's going into concrete anyway. It can be used alongside other admixtures, or it could be used as a standalone admixture. And we're seeing improvements such as 40% of compressive strength, increased durability, both in water penetration and chloride migration. In some cases, getting better early strength, more workability, and we've also proven that we can reduce CO2 emissions. So just some highlights of results, not just improving one feature, but because of graphene's multifunctionality, we can also improve multiple characteristics at the same time. So we can improve compression strength, elastic modulus, and water permeability when we get the right graphene concentration. So most of our work is done using independent test bodies, but now we're starting to bring our own in-house testing online. With Banniger Precast, we've reported this as an RNS in 2023. So we have some impressive results where, first of all, we looked at how we can improve the properties of their existing mix design. And we showed after 1 day, we can get 33% improvement, which is fantastic. If you can demold quicker, you can produce the precast structures much quicker, but also you're getting stronger concrete after 28 days. One of the other benefits is chloride migration. So if you can reduce chloride permeation through a structure, then you can minimize corrosion of the steel reinforcement. So again, creating longer lasting, more durable structures. We then took those results and we looked at how much cement we can actually reduce. And we were able to maintain the same performance with 20% less cement. So that's taking about 100 kilos of cement out of their mix and replacing it with only a few kilos of our graphene admixture. We've then done further work this year, and with that same mix design, we've now cast some real life structures. We've been looking at traffic walls and putting those in the real life operational environment, and those will be studied over a 36-month period. Visual inspection and ensuring that graphene is not causing any unforeseen issues with the durability and the lifetime of those structures. So that's ongoing, and we're also now working with further trials with Banniger to further optimize the cement reduction that we're already observing. So back in July, we had a placing, and some of that money was to be invested in our own concrete and mortar testing. So we've ordered that, and we're expecting some of it has arrived. We're expecting commissioning to take place in mid-January, and that will enable us to accelerate the 17 developments and also improve our quality control or establish a quality control procedure for our 3D printed products. We've also been able to purchase some second-hand equipment and also additional molds that will allow us to increase our capability for how much concrete we can test at one time, and also water tanks that will allow for curing of more concrete samples. So to summarize the 17 aspect, we've demonstrated now improvements to a number of mix designs. We still have more work to do and more confidence to build with our mix, and also optimizing our 17 recipe. We've got trials ongoing with a number of ready mix companies and precast concrete companies in the UK and now in Brazil through Soma and Montana. With our new in-house testing, we're hoping to rapidly build confidence and to accelerate our testing towards BSE 934, which is the admixture standard, and also going for the equivalent standard in Brazil to make sure that these products can be legally sold in different territories. I'm going to pass over to Ben to talk through the 3D construction activity. Thanks, Ben.
Hello, everyone. So I'm Ben Harries. I'm a former architect and current head of 3D construction printing, or 3DCP, at Versarien Plc. I thought it'd be a good idea to start with some of the key benefits of 3DCP, just as a primer for those who aren't familiar, and why it's kind of important, really. So firstly, our process, as you can see down the bottom there, is quick and convenient. In-house, we can design, visualize, and print parts, and we can go from design to production in a matter of hours. So compared to other methods, it's incredibly quick. Reducing carbon in the printing mix. So the mix we use is up to 32% reduction in CO2 emitted in the production of the printing water. More on this later as we're looking to further improve in this respect. Reduce labour, so there's no workers handling concrete or building or striking formwork on site. The modules are printed robotically under controlled conditions and then shipped. Material and weight reduction can be significant, with material savings of over 50% possible in certain scenarios when compared with solid cast options. The weight saving also then creates knock-on effects in terms of carbon savings during transport and handling. I mentioned formwork, so not just the labour, but cost, time, wasted material, and carbon associated with formwork is then eliminated, which is a big benefit. Quality control, so robotic manufacture of the modules under controlled factory conditions, combined with close monitoring during the print process, allows us to have precise, repeatable results. And our new equipment, as Steve mentioned, will also allow us to perform tests on our material to ensure that each batch is performing as expected. Program reduction, so not needing to have tooling produced can drastically reduce lead-in times, and most of our modules are printed within the hour. Design freedom, really important, so we're able to create more creative, fluid, organic forms, which would be difficult, too expensive, or too time-consuming, or possibly even completely unfeasible to produce through traditional casting methods. And then easy sensor integration, which is increasingly important as we look to make our buildings smarter and embrace the implementation of things like digital twins for an increasing number of asset types. Next slide, please. So this head wall, which was produced in collaboration with Costain and National Highways, is now in place on site, and the project has been successfully concluded. This was a good demonstration of some of the benefits I just mentioned. By leveraging the ability of 3DCP to print curved forms and complex geometries, we're able to achieve strength geometrically as opposed to through the abundant use of steel reinforcement. In fact, all of the steel was omitted from the walls in this piece, and the only steel that was left was there in the base, and this was needed to comply with Costain's own lifting and handling procedures. Next slide, please. Okay, so this is Charter Street. So this is by far our largest 3D CP project. This is working with Building for Humanity in Accrington. The project will comprise 46 apartments spread over 5 blocks. The first phase, for which we have been appointed, will consist of the first 3-story block and the community hub. For this, we're acting as print partners for our clients. So this is a slight departure from our normal operating procedure, but quite significant. So what this means in real terms is that in the design phase, we're attending design team meetings along with the rest of the design team, architect, structural engineer, M&E, etc., providing professional consultancy services such as design support and technical input. And in the construction phase, our people will operate the client's 3D CP robot to get the building envelopes printed. This is a significant step, really, not only because of the scale of the project, but also because it shows that beyond our factory production capabilities, our know-how and experience are also a valuable commodity. This will also significantly give us multi-platform experience, which is very rare in the 3D CP sectors, as almost all players in the space are tied to a single platform, which has a specific set of capabilities. Can we play the video now, please? This is just a quick video that you're going to see now demonstrating the construction sequence. It's just a simple video. So there you can see the ground floor slab. And what we're doing is so this is the robot that we'll be using with our clients at Building for Humanity. So as you can see, what we're doing is we're printing walls at the ground floor, each from one position on each side of the building. Then we're moving it up, we're craning it up onto the next level, printing the walls, installing the next floor, and repeating the process. At the end of the process, of course, all the usual fit out will happen, as always happens with buildings. That will be finished to the design team's specifications. It will look very much like a traditional building. And this is to comply with planning and planning especially. I think there's a limited appetite for unusual looking 3D printed buildings at the moment, so it's a softly approach at the moment. Next slide, please, Steve, once we're... Okay, so this Chinese gateway project will be a world first, very exciting, and is to be constructed in the heart of Birmingham, Chinatown. So having successfully completed the first phase, which was the feasibility study, we're due to commence the design phase early next year, moving through to the printing and construction phases as we move towards the end of 2025, pending appointment on those elements. So the Balfour Beatty Print Build Zero contract is to develop graphene-enhanced mortars with Balfour Beatty, obviously. And this is significant for two key reasons, I think. Firstly, it represents a further opportunity to commercialize graphene and demonstrate the benefits for construction methods of the future. Not just that, but in partnership with a leading and trusted name in construction. Secondly, all commercially available printable mortar mixes are currently shipped from overseas, adding additional cost, time, complexity, and carbon to the process. The UK, therefore, must establish its own production capacity and supply chain for printable mortar mixes if we're serious about adopting this technology in a sustainable way. The project also includes the production of printed test pieces in order to demonstrate the performance and commercial viability of printed assets going forward. And we're also collaborating on a separate technological showcase for 2025. Versarien has a growing number of construction partners operating across all sectors. And as a founder member of the National Highways Roads Research Alliance and a partner in the Digital Roads of the Future programme, we're committed to developing further opportunities and applications in the highway sector, of course. So this year, we've also completed a review of 3D CP methods and critical aspects of the physical and mechanical properties of printed materials for the Office for Product Safety and Standards, OPSS. This was an extensive review and will be an important platform for standards development going forward, so great to have been involved in that. We've also taken on our first apprentice in partnership with Accel, the UK's first industry-led construction school. Our lead 3TCP operative, Annetta, was shortlisted for a Women in Construction Award in the On the Tools category, which was great to see. And in 2025, we will be collaborating with Digital Catapult, setting challenges for the development of artificial intelligence tools to accelerate the use of AI in the 3D construction printing industry. Thank you.
Thank you, Ben. I think we'll pass over to Roberto now to talk us through energy and mobility.
Thank you, Steve. So, good afternoon, everyone. This is Roberto Clemente. I'm the CEO of Nanomat, one of the companies of the PLC that we are devoted to the development of advanced materials in the area of energy, not exclusively energy, but today I will talk specifically about this part. So, can we go to the next one, please? So basically that we have is a platform for the developments of nanomaterials. This platform is very versatile and allow us to manufacture and design hundreds, literally hundreds of materials with very different properties. So a collection of these materials was developed specifically for the area or be part of electrodes of the energy storage device that we are calling the nanocaps. The nanocaps, they have a very interesting profile. If we take a look to this Ragon plot, we can see that there are different energy storage technologies with a high energy, but with a limited power. Whereas there's other, like the EDCL, the so-called supercapacitors, that they have a high power, but a limited amount of energy. So the energy storage devices that we are developing and we brought out already to the prototype level, they have a very interesting profile to address one specific niche that it has a number of opportunities into the market. So we can go to the next one. However, there is not only restricted to this pair of energy power where these devices, these nanocaps, they have major opportunities. If we see the part of the explosion risk, the current standard technology in the market, the lithium-ion batteries, they have this risk of explosion that it makes a major problem in different situations. In addition, with the technology that we have is eco-friendly, that allows us to be used in some situation where there could be ecological problems and restrictions. So if we go to the next one, Steve, please. If we take a look to the market, there are some very interesting and descriptive opportunities and applications that we can remark. One of them, for instance, are the AGVs, these automated guided vehicles that when they are operating at X atmospheres, they have to avoid any potential situation of explosion. So it can be a very clear substitute technology for the lithium batteries in that specific application. Additionally, when we go to the airports and aircrafts, we have interactions with these final end users. They're trying to avoid any kind of safety problems in there because it had happened previously, and we probably heard about that, about problems of explosions of lithium-ion batteries. There are a number of different situations where these nanocaps can be used because the problem or the risk of explosion is completely new. Another very descriptive application would be the cranes in ports, where there could be eventually, with other alternatives, there could be leak of the electrolytes and can make problems of ecological problems with the drop of with the leak of this solvents into the marine. However, again, our technology can provide this can provide the power required for these cranes. We can even increase the time that we are providing energy because the profile is very good in terms of energy compared with the supercapacitors, and there is not any ecological risk using this. In addition, there are a number of other applications where the supercast has been working in the last decade, like trains or pitch control, where we can introduce these technologies. So one of the major challenges that it has this kind of technologies is the adoption of the technologies by the end customers. Our strategy is to integrate from the very beginning all the partners of the value chains, not just universities or development centers, but also the end users, because they can accelerate our developments and also to confirm that there is an opportunity there. In here we mentioned some of these end customers and also some of the partners. And to remark that we are a member of different industrial platforms with a vertical of the energy storage, but not just energy storage. As I also mentioned before, our platform has other verticals like the functional printing that we will refer later. A very nice example of this strategy is the collaboration that we have with the mining company in Brazil, CBMM. We are working in the development of advanced materials, bringing the niobium, where the most important materials for them, obtaining very interesting results in the area of novel supercaps. We are finishing this collaboration, but we are working at this point to extend this collaboration for more interesting projects in the next months.
Thanks, Roberto. So moving on to electronics, which is the fourth strategic research area outlined by IAM4EU. In the last few years, we've already established our graphinks portfolio of functional inks for conductive printing, inks tailored for things like wearable devices. In recent times, we've been seeing increased sales of these products, not just the ink, but also developing our own prototyping services. We've been doing lots of work on wearable heaters and printing those using facilities we now have in Longhope in Gloucestershire on polyester and also onto flexible or conformable substrates such as DuPont's Intexar polyurethane films. In the last sort of 6 months, we have been working, our Cambridge Graphene team, on an ImpressMade project. This is European funding, looking at a near-field communication antenna that we had in mind to develop. One of the challenges with printed electronics is the use of lots of metal, lots of silver, non-biodegradable substrates such as polyester. So our intention was to look at developing a new ink formulation that could be more ecologically friendly, has better conductivity to meet the specs of near-field communication, and could also be printed on recyclable, biodegradable substrates. So we just presented this work in Brussels last week. Our colleague Daniele, one of our senior scientists, was out there showcasing the improvements that we've made. And really what we've done is created now a hybrid ink between graphene and silver with a significantly low amount of silver, but with almost five times or more the increased conductivity of our graphene ink. So that's enabling us to now access other applications that weren't possible before with just our graphene ink formulations. Roberto?
From Nanomat, in the last 18 months, we've been working in a project, the Innova project. Is a project funded by the IFEX, an institution, a Spanish institution here, and that awarded us with a grant of up to 415,000 euros for the development of the new facilities, a new portfolio of conductive inks. Along this project that we've done is to design new inks that, in addition, that they are completely part of the Versarien portfolio, that is in addition to those that before existed, increasing the possibilities to acquire more and different alternative inks for the final customers. That we've acquired is the equipment to make a new pilot plant for the manufacturing of these products, and also we applied for a patent and also made a trademark. That basically all these efforts were aligned to launch a new business line that will be on the market in the following months.
Okay. So this week we've also announced the signing of a distribution agreement. So we're now accessing more higher tech products, working with MCK Tech and a barrister company. So this is a graphene barrister sensor platform that can be utilized by medical diagnostics companies. So barrister is not a novel technology, but it's been around since around 2012, published in Science by Professor Hyun-Jong Chung, who is now the CEO of a barrister company. So with this device, what we're doing is overcoming a lot of the limitations that are existing from graphene-based field effect transistors. So the beauty of the barrister is that we can achieve high on-off ratios, and we can have sensors with sensitivity which are orders of magnitude higher than the current state of the art. So really, this is a technology that can revolutionize rapid point-of-care diagnostics. We'll be providing these chips, which are already with a surface functionalization that can be modified by the end customer or can be tailored to suit whatever the customer is intending to put on the graphene surface. So as you know, with graphene, it's a great sensing platform, but you must carefully functionalize the surface to enable you to detect specific viruses, bacteria, diseases. And so we'll be providing an intermediate product to the diagnostics companies such that they can further develop their enhanced sensing systems. And this comes, again, the technology is not just for biosensing, but can be adapted, can be used to monitor things like gases, chemicals, temperature sensing. And the ultimate challenge and the vision is to create a multi-sensory platform that can minimize a number of devices into one chip. Moving on to commercially funded R&D and grants. So essentially, we're active and we have a track record in a number of industries. We've obviously developed lots of prototypes, and we've had Innovate UK funding in a number of areas. The Airbus project we worked with for the last 3 to 4 years on aircraft de-icing. We're now looking for grant funding to take that further and to enhance the TRL level to push it through to commercialization. And so we're exploring R&D opportunities in a range of these fields, but predominantly focusing on areas that, as I mentioned, are key to the future of Versarien, the construction, energy, electronics, and so on. But we also talk a lot about commercial R&D, and just to explain what that means, that means the project is fully funded or it's jointly funded by a commercial partner. And we perform commercial R&D in a number of areas, particularly developing novel materials, as you've seen from the likes of Balfour Beatty and CBMM. We've talked about these companies are funding these R&D programs. And so we've now got a number of large global companies on board that are funding R&D with us. So in the last year, just to highlight a few key projects, CBMM has been one. We've also had a project with a UK aviation company that we can't talk about much. And the other significant one has been IRPC. So just to give you a summary of this is a Thailand-based listed company, part of a large group called PTT. And they funded Nanomats initially to work on a 9-month project to co-develop advanced materials. So they were supplying materials to Nanomat to be functionalized using our pilot scale chemistry functionalization. And those products were then being supplied to Versarien in the UK, so Cambridge Graphene and 2D Tech were utilizing those materials to put into different products and perform some material characterization and product testing. So utilizing all of the skills within the subsidiary to ensure that we can deliver these projects on time and achieve the targets of the customer. So these are incredibly important, and we see more of these opportunities coming. In terms of grants, we've been very successful in the last 10 years. In the UK, we've won more than 16 Innovate UK projects to date, and we've been a core partner within the European Commission's Graphene Flagship Programme. Nanomat itself has also been able to fund almost half of its operating costs through grants and public funding. So we do see grants, in the next few years to be also critical to the future of Versarien and supporting us till we get that full commercial traction. And currently we're awaiting the outcome of 4 grants, 3 from UK subsidiaries and 1 from Nanomat. So hopefully we can provide updates on those to the market when we receive feedback. So a lot of our commercialization and the traction is really underpinned by, there's currently a lack of standardization and regulations and understanding of nanosafety in the industry. And so we're working quite closely with a number of bodies to help support the understanding of graphene. So in terms of verification, we were the first company to be a verified graphene producer, which is a procedure administered by the Graphene Council in the US. And several others have now followed in our footsteps. So I think it's gaining credence. And we've been through that process now a second time. We're also supporting the Graphene Council in its aims to get the graphene classification framework into an ASTM standard. And so we've recently signed up to ASTM to be able to provide expert insights into pushing that forwards. In South Korea, we are supported by a 5-year program from SKK University, and that's to help develop graphene standards within IEC TC 113. So we're looking at projects which are understanding defect characterization within graphene and other 2D materials. And so I've been presenting Versarien and our work in terms of REACH regulation at a number of events hosted by BSI and also by other institutes in Korea. In terms of regulation, we maintain both EU and UK REACH registered up to 10 tonnes per year for graphene manufacturing. And I remain chair of the REACH committee's technical working group. And also we have reinitiated the graphene flagships ECHA REACH committee. So we're having those engagements and conversations with all of the relevant parties that are regulating the graphene industry to ensure that we stay on top of any changes or any future changes or requirements that might be necessary for doing nanotoxicology testing. So on that front, we've been quite active in, again, European projects focused on the application of graphene in a number of areas and looking at any potential nanotoxic effects that might come down the line. So again, it's very important, and we're working with 2 other graphene companies to supply graphene in concrete and also in electric vehicle tires, so graphene in rubber composites, and understanding graphene in the life cycle. How will the manufacturers be exposed to graphene particles, and is it toxic? And also, once it's in a complex matrix, once it's in a concrete structure, and we start drilling or abrading that, how are people going to be exposed to these materials? What concentration of graphene could they be exposed to? And is it going to be harmful? So again, lots of unanswered questions. And this is a 4-year program where we are now collecting those dusts and having them analyzed by our partners in the project. And again, hopefully provides very valuable information that we can give confidence to the market that graphene is safe and can be put into a number of products without having fears of any potential long-term effects. So just to summarize, hopefully we've answered quite a lot of questions, but I just want to state, we are growing our commercial and grant pipelines. We've seen those increase quite a lot over the last year. We've increased our product offerings, namely, over the last year, but also this week, where we've now started to launch products in the healthcare sector for diagnostics. We're winning larger commercial contracts with global leaders. That's evident with our contracts with the likes of Balfour Beatty, CBMM, Building for Humanity, and hopefully those continue. We're achieving a series of UK industry firsts, perhaps world firsts, with our 3D printed Chinese gate, but certainly, doing the first 3D construction of homes in the UK will be a massive industry first. We're engaging with more industry sectors. I mentioned healthcare as one, which is a growing industry for us. We're nurturing talent and leadership within the company. Our staff certainly are developing more and learning more skills. Ben talked about the potential AI skills that we can bring on board. We're also, as I say, investing in our in-house technical offering, and our staff are now learning about construction testing and what's necessary in terms of, again, building that confidence within the team that our products are fit for purpose and they can really be game-changing in their different industries. And with that, I'd just like to say we're focusing now on areas that will deliver. We're aligning with the vision that Europe has in terms of construction, energy, mobility, and electronics, and hopefully, as I say, those will deliver for Versarien and generate a bright future for us. So thank you for that. And Tim, I'll pass back to you for leading on the questions and answers.
Well, thank you very much, Steve. And thank you very much to everybody who's been typing in questions and comments as the presentation's been ongoing. Hopefully you will have seen that we addressed all those questions that we could, that were sent in advance of the presentation while Steve and the team were going through it. So my list I've been rapidly ticking off, and fortunately, given we've only got 6 minutes left of the scheduled time, there's a shorter list. Also, people have been asking about various historic project information and corporate information. A lot of that is available in the company's latest annual report and on the website, so I do encourage people to look there. There are also one or two points made that unfortunately, particularly of a financial nature, that we can't address in a forum like this and can only be addressed through regulatory announcements. Final point, a number of people have asked, and one said, seriously blown away but can't keep up. So will a recording be available? The intention is yes, a recording will be available in due course once it's been processed on the company's website, so you can look at it at your leisure. But I have got a few points of clarification that I've been jotting down from the things that have been coming through. Steve, one questioner says, what does Versarien do to protect its patents and IP?
It's a good question, Tim. We do everything we can to look and ensure that companies aren't infringing. Where we have had issues, for example, we've only come across issues on sort of trademark infringement. We have tried to defend as much as we can, but it's an expensive business, and we don't necessarily have the resources to protect our IP in all of these territories. So, in some cases, yeah, there's very little we can actually do, except send maybe a polite letter.
Indeed. You talk a lot about grants, and obviously grant funding is quite important. Is there any sort of general comments you can make about the shape of the sorts of grants you're seeing? Are they matched funding, or are some of them covering all of project costs, or are they all different?
They're all different. It depends where you're applying. So in some cases, European funding is often 100% funded, and it doesn't mean that it means that Versarien doesn't have to contribute anything. Of course, as a board and as a company, we look at what are the additional costs to the business and make sure that we're not, spending money in the wrong areas. But yes, you're right. In some cases, there is an element that the board will have to put up 30% of the total grant income to facilitate that project. And again, we assess those, and we agree as a board whether or not we'll take those on. I don't know if Chris, if you have anything to add on that point.
I guess I would add something, which is in many cases it's about assessing what the incremental cost is of getting involved in that particular project. And of course, a lot of costs of a project are staff costs, and we're already employing those staff. So just because it's a £100,000 grant doesn't mean to say it costs us 30,000 extra. Some of those costs are already being incurred and be attributed to that particular grant income. But as Steve says, they are all different.
Thank you. You mentioned obviously the in-house test equipment that's coming on stream early in the new year. How much do you think that's going to contribute to accelerating the research that you're doing, and indeed the certification, particularly of cementine?
Yeah, it's difficult to put a number on that. Of course, concrete testing is notoriously slow. We have to wait at least 28 days to get a result. But what it does is it allows us to, get a quick assessment after 7 days whether our graphene or whatever is going to enhance the concrete in a way that we expect it, and we can then tailor and we can tweak things. When we're doing things independently, it's very difficult to make changes on the fly. It's an expensive process. So hopefully bringing it in will, I say, shorten it from years to months rather than, it's not going to be days. But as I say, it's also an essential investment for ensuring that anything that we print, which is 3D printed, and we deliver to a customer, is also safe and is meeting the expectations. That's so there's two benefits to having this equipment on site.
And I'm conscious we've got a minute, and hopefully we've covered them. One I've just had in, graphene, has been around for nearly 20 years now. Obviously, Versarien's been around for a while. Do you think the market is now coming towards graphene, and the landscape is changing, and people are finally understanding the benefits it can bring?
Yeah, I think it's still relatively early in the journey. 20 years seems a long time, but technologies such as carbon fiber, were around since the 1960s, and only 60 years later we're seeing those sort of getting into all different markets. So I think these technologies take time. There's more barriers now than there used to be with other technologies. So we have more regulation, more red tape around getting things to market, which is a good thing in terms of we don't want to release any products which are dangerous, and going to be harmful. So we have to work together as an industry to overcome these challenges. But yeah, I think there's certainly been, since post-COVID, I think we're now starting to see companies with more ambition to change and to spend money on R&D and to enhance their products rather than just sit and wait. So I think the tide is changing. Whether we're coming out of that trough of disillusionment or not, I think there's lots of articles out there suggesting we are, but I think we still have a way to go. We'll still see some consolidation of the market, and let's see what happens in the next 5 to 10 years.
Yeah, but Versarien certainly seems to be well positioned in the key markets to take advantage of it. Okay, well, we're 1 minute over now. The last couple of things have just been kind words to the presenting team. I'd like to echo those and say thank you very much for Ben, Chris, Steve, and Roberto. But most of all, thank you very much to everybody who's joined today. Any further questions, please do not hesitate to get in touch. And as I say, we'll endeavour to make a recording of tonight's event available to everybody. So thank you very much and enjoy the rest of your evening.